This seems like it could be helpful. I don't know. It's not necessarily, that's just like the font though. Formatting. Prove that all the cube numbers are either multiple of 9 or one more or less than a multiple of 9. Really? That's a crazy fact. I didn't even know that. And Joker, you're asking, do you guys have a recommendation for a statistics book? So you're interested in the Johnson SU distribution, but it seems kind of niche. I never heard of the Johnson SU distribution. No, I have very poor knowledge of like math books in general, and especially with stats. So I'm sorry, I don't have a good recommendation for you. Hey, Club. So I'm just gonna look a little bit more into this. Oh, okay. Thank you, Zach, for finding that. Okay, so and hey, Jeff. Ooh, 3-watch streak, nice. Okay, so let's go over to Thunder's question. I don't know if I'll be able to do it. I wonder if it's gonna be another induction one, or I don't know if you can do this inductively, or maybe you just do it even algebraically. But prove all cube numbers are either a multiple of 9 or one more or less than a multiple of 9. Or one more or one less than 9. Multiple of 9, but okay, so I guess would we take our cube number as, let's just say, n cubed, and we would want to show that I'll say want to show n cubed is equal to 9k, or n cubed is equal to 9k plus 1, or n cubed is equal to 9k minus 1. N cubed mod 9 member 018? Oh, it might be a modulus thing. I don't know modulus like arithmetic though. That's a good call though. Oh man, you're probably right, Jeff. Thunder, have you done mod before? It's proof by deduction. Oh, okay. I bet that there's a way with a mod for this, but if we have to use deduction, I think deduction is just like working on it algebraically. Like we need to find how would we do this? Do we need maybe some fact about multiples of 9? That could be it. So we have to check 9 cases. Numeric written 9m plus k. you send the answer but you don't understand it. That might be helpful too, Thunder. Or it might be a thing where like we use, it's basically like a modulus argument without actually using it. Okay, here, let me a screenshot? Okay. Okay, I was wondering if you have to use like divisibility with 3 if we're not. Okay. Thank you for that. So break down the integers into numbers divisible by 3 and numbers giving a remainder of 1 or 2 when divided by 3. Really? Yeah, because why is it 3? I know that 3 is a factor of 9. Multiple of 9 is also multiple of 3. But if I'm doing the problem blind, I don't know if I would think to do that. What's up, Cloud? So hi, Gut Safe. It's a cube on the snow. How deep will it sink? That's a good question. I don't know if I can do that, Cloud. I can try to like Google it after this, but I'm not sure off the top of my head how you would approach that. So I think you know what, Thunder? I think that this is an educated guess using the divisibility by 3 thing. Oh, hey, Bob. Ln is either 3k minus 1, 3k, or 3k plus 1. Cube and chill. It's like it makes sense when I actually like see it done out. But the thing is, like, how do we like realize that we're supposed to do that for our first step? I think that's Hunter's question here. It was like 4 hours, Bob, or something. We had a good long session. So Thunder, if you used it with 2, which I don't think 2 would actually work. Yeah, it was a ton of fun. Aller, thanks for the follow. If you use 2, 2k plus 2 actually doesn't make sense there. It's the same thing as just 2k. When we're talking about like divisibility. And it's basically like every time you go up a number, you need another like factor, I guess. So if it's 2k, you check 2k and 2k plus 1. If it's 3k, you check 3k, 3k plus 1, 3k plus 2. If it's 4k, you check 4k, 4k plus 1, 4k plus 2, 4k plus 3. But it's like in theory, you could try and look at numbers like that, Thunder. I think in this particular case, it wouldn't be helpful because we're dealing with 9. What is factoring? Like, what does it mean to factor something, Aller? Or like, how do you do it? Or okay, you said yes to what does it actually mean? Let finish my train of thought here with Hunter's question. And then actually, Cloud also asked a question before that. I'm not sure if we'll do Clouds though. Or like second, but really first. Are you neat? No, I graduated 5 years ago-ish. I have a bachelor's in applied math. So yeah, that's I think Thunder that wouldn't. I think if you could do it where you check 9K, 9K plus 1, 9K plus 2, all the way up to 9K plus 8, and show that every single one of those just, you'd have to, if you did it that way, you have to show every single one of those boils down into one of the three cases that the question states. And I think this doing multiples of 3 thing is like a time-saving thing. And they do that because they already knew that it would happen to work out because 3 is the square root of 9. Or, 3 is a factor of 9. So I think this 3n thing just saves us work. But you could check 9K, 9K plus 1, 9K plus 2, ... all the way up to 9K plus 8. And for each individual one, you'd have to show they fit into one of the 3 cases given in the question. But you have to check 8 and 7. -1 and 1. Well, so if we were doing it that way, -1 is 8, basically what Jeff said. So basically, like, that's what we want to show, so we can't actually, like, assume this is a fact yet. What you would do is you would check, you'd start out by checking a case where we have 3, I'll just say L because I'm out of letters. We have to show that 3L cubed fits into one of these 3 cases. In this case, it's pretty clear that 9 times anything is a multiple of 9, so it fits into the first case. And then we'd have to, I'm sorry, not 3, but 9. Cubed, 9 cubed, 9 cubed. That doesn't feel right, does it? 9L plus 1, there we go. Cubed. Then you'd have to do like some factoring here and figure out which one of these 3 cases it fits into. You'd have to go all the way down the list. So I think this strategy would work. It's just a bunch of work. And that 3 thing is a nice time-saving shortcut. And I forgot to take my webcam down. I went to the board, but it's okay. He should be older than you to 25. I'm guessing you're younger. I have no idea how old Zach is, but I'm 26. You see it? Okay. Glad to help. So I do think that the whole thing with making it 3, it's a good thing to try it if you notice it. But I think if you're doing this problem blind, not knowing the answer, it's kind of a leap of faith of something that you're just trying to see if it works. And you don't necessarily know that it's going to work going into it, unless you're older. Okay. So I think that's the best advice that I can give you for that problem, where like, if you're used to these problems, that's probably a thing that you would try first to divisibility by 3, but the strategy that you're saying basically works too. And Aller, if you're still here, really basic question, but what is factoring? It's a good question to ask because people don't normally really explain like what it is, I guess. So I know you're not asking how to do it, more just like what it is, but just so we have an example to look at. If we had x squared plus, what's a good example? Maybe 3x plus 2. just as, you know, so we're on the same page with what factoring is. It's when we go from something like this, but potentially, to this. Not that, +1. Or factoring can also be going from 2x plus 4 to 2 times x plus 2. And factoring, it doesn't change the value of the problem at all. Like, these equal signs are completely valid. What it does is it usually puts things into a nicer format that in certain contexts are more helpful. So like if you're solving for the zeros of a quadratic, you need it to be factored or use the quadratic formula, but often you just want to factor it because this puts it into a very easy format to solve for x here if you have a 0 on the other side here. And in a case like this, where you just factor out a constant, it can be helpful because sometimes, you know, you have a fraction involved, and like if you had something like 2x plus 4 over x plus 2, we could do the same factoring up top, and we get a nice cancellation here. Like that's an example of where, like, why we would want to factor something. And it all relies on something called the distributive property, which is basically if you have the situation A times B plus C, the distributive property says that the A gets distributed to the B and the C, so it's equal to AB plus AC. And factoring is the reverse direction of this. When you go from this back to that, irreducibles and integral domains. So yeah, there's a variety of situations where factoring may be a good idea, and there's also situations where factoring isn't a good idea. It kind of depends on the context and why you're doing the problem in the first place. I hope that at least kind of semi-answers your question. It's a little bit like open-ended, so if there's an aspect of it that I didn't quite cover that you want to ask me about, please do, but I think I'll stop there for now and let me know if there's something more specifically you wanted to hear about, or if that covered it. Okay, let's take a look at your question, Thunder. Thanks for finding that, Jeff. So for any positive numbers p and q, p plus q is greater than root 4pq. Just part A? Is this triangle inequality? Square both sides and factor? Oh, same method as last time? Okay, let's try that then. I think I was getting too fancy, and Jeff is probably right. Glass worked even after looking at the mark scheme. Oh god, okay. Let's see if we can get to the right answer. So wait, you've been working on the A levels, right? Like, have you actually taken them yet? I'm not sure exactly how they work. So let's follow Jeff's train of thought. Greater than, is that or equal to? Or equal to root 4pq. So just see if it works out algebraically. And basically, let's get all the p's and q's on the same side and get something that we can hopefully factor and get some meaning out of. So first, I guess let's square each side like Jeff said. P plus q squared is greater than, we don't need to flip this because squaring doesn't affect inequalities. I don't think, at least. And then the squared square root goes away. Multiply out the parentheses there. P squared plus 2pq plus q squared is greater than or equal to 4pq. Do we have any positive numbers p and q? Hey, Stooky. Got an exam on them in a year. Oh, okay. Oh, yeah, and so we're given that p and q are positive numbers. So we don't have to worry about that, but I forgot about that, to be honest. Okay, remarkable dev people show everything on the left. Oh, okay. Okay, so let's subtract over the 4pq. That definitely doesn't force us to flip the sign. We get minus 2pq plus q squared greater than or equal to 0. And now this factors to p minus q squared greater than or equal to 0. So what are we, for any positive numbers p and q? Aha, okay, and so this is what we need because p and q are positive numbers. And this statement is true for every p and q. Because true for all p comma q belong to, oh my god, how do you say like positive numbers? So I guess it'd be all real numbers, because even if q is greater than p, you always square it so it turns, the overall thing turns positive. So this is always greater than 0. Yeah, it's like the square. No matter if they're equal to each other, we get 0. 0 is greater than or equal to 0. If p is greater than q, then it's a positive number anyway, and we square it, it's still greater than 0. So no matter what here with p and q, we've proven it just from there. So does that make sense, Thunder, or what part were you not comfortable with there? They want more, really? Do they want to actually explain this bit more? It's like, I guess we could say, we could actually like break it down into 3 cases where p is greater than q, p equals q, and p less than q. Oh yeah, sure. If we really wanted to like write this thing out, it's a lot more confusing. Let's see. See if we can figure out what they did. To reverse the order of the steps, then run into the issue. Where you're square rooting each side. Huh. They're only working with one side of the inequality here. This statement I'm trying to work out. I think we're stuck on the same part of it. Oh, that's true. I did assume the thing that we're trying to prove. Thank you for that, Stu. Yeah. I do that way too much. Because my proof skills are just not good. Okay, so oh, obviously you've never seen hash functions, Jeff. Although I'm pretty sure they are reversible, just takes too much work. So with this first part up here, p plus q squared consider it, trust me. So Thunder, I mean, so I before I even like try to look back at like what I did on the board, I want to make sure that we're on the same page with what happened here with Thunder. So their entire goal with this very first part was to just in any way engineer a 4pq to be involved. Like they start only with p plus q squared, and they do whatever they have to do to get a 4pq to appear here. And so what they did is they split up this 2pq into a plus 4pq and a minus 2pq, and they factored it to be p minus q squared and left the 4pq out. And now this is where we want to compress it to get something more like, I guess, helpful to the actual question. So since p minus q squared is greater than 0, as they say, we know that our initial left-hand side, p plus q squared, must be something more than the 4pq here because of this term being greater than or equal to 0. It's very weird that, you know, we do this work just to like leave it off, but our end goal was, or not our end goal, but our goal for the first like half of this proof was to get to p plus q squared is greater than or equal to 4pq. And then from there, it's a matter of square rooting each side and justifying it. You don't know what I just said? That's fair. Maybe I'll try to explain it on the board. So I think it's important to understand like how the answer key is stated, because I assume that's how Thunder is going to have to like do questions more in the future. So I guess you could technically take my steps and reverse them, but I'd rather, let me just go to blue here. So all they have is this stuff, and they start by just trying to get a or you know, they have this like want to show, so they start by looking at p plus q and squaring it. It seems natural because there's a square root involved on the other side. So let's just examine what p plus q squared actually is, which is p squared plus 2pq plus q squared. And we just want to get a 4pq involved anywhere in this so we can somehow eventually get to that right-hand side. Because I made a logical error here where I assumed the thing we want to prove is already true. and that's not good. So we can force a 4PQ to be in here if we say that 2PQ is equal to plus 4PQ minus 2PQ plus Q squared. And I think this part you might already understand, so I'm sorry if I'm over-explaining it, but this part, it's going to be important that like we're on the same page here. Cowabunga. Hey, Jed. And so then, leaving out the 4PQ, being all the way to the right, they factor just the P squared minus 2PQ and the Q squared into P minus Q squared plus 4PQ. And we don't care about P minus Q squared. We only care about the relationship between P plus Q, because P plus Q is what we have up there, and 4PQ, because that's what we have on the right-hand side. And we can get the inequality involved in the mix at this step. You're with me so far? Okay, good. Thanks for saying that. So rather than saying that P plus Q squared is equal to this whole right-hand side, we know that P minus Q squared must be greater than or equal to 0 because P and Q are both positive numbers. So we could just chop this entire part off wholesale and change that into a greater than or equal to sign. And it's still a valid statement. P plus Q squared is greater than or equal to 4PQ. And that's just doing anything we have to do to get a format that matches our initial step. So we know P minus Q squared is some positive number. And so if we remove this positive number out from this equation, without changing the left-hand side, we know the left-hand side must be greater than whatever's like left over, greater than or equal to. So it's doing a whole bunch of very awkward math just to match our original step. That's crazy. Jeff is saying, wait. You don't know that adding a positive number doesn't make it greater. P minus Q squared could put it over? Are you saying there's a situation where P minus Q squared plus 4PQ is not greater than or equal to 4PQ? So that's basically the claim, oops, squared. It's basically the claim that we're making as like a sub-step here. So I don't see that's ever not true. Get saved. Thanks for the follow. When you use your assumption, it's not an assumption, it's given in the problem that P and Q are positive numbers. Positive numbers P and Q. I mean, I didn't actually state it, but I mean, I guess I verbally said that P minus Q squared must be greater than or equal to 0 because of this positive number thing. Fried brain. So, I mean, it's not like the most rigorous proof, sure, but it's still... That's true too. I guess you don't have to use it. It's not invalid if you do use it. It's just extra work, I guess. I think that's overthinking it, Jeff. It's using given information from the problem, and then in part B, we're no longer given that information. So the proof already doesn't apply. Wait, okay, I'm confused on what you're saying then, Jeff. I guess. I'm saying P plus Q greater than or equal to root 4PQ implies, or if and only if. I guess? Yeah? Are you saying that I've done something wrong, or are you building towards part B right now? And Thunder, you're saying you have a similar question. Couldn't the P minus Q squared in P minus Q squared plus 4PQ cause it to be greater than P plus Q squared? Um... No, I think we've shown that. So you're saying that like we've shown that this is already like equal to each other. So the P minus Q squared wouldn't put it over. Um, it's more like, even forgetting about the left-hand side here, we know that P minus Q squared plus 4PQ must be greater than or equal to 4PQ. And so if this relationship between these two equations in a vacuum is true, you can kind of cut out the middle part and say that P plus Q squared is greater than or equal to 4PQ, I guess. If I'm understanding your question right. And if I misread it, then I'm sorry. Whereas if the P minus Q squared you get it somewhat now? Okay. You lost for part B now? Okay. For part B, they say specifically to show by means of a counterexample, so we get to, I think we just get to forget about the entire proof that we just did, thankfully. Because we just need to find a pair of negative numbers that makes this untrue. And this is going to be, I think you can take almost any two negative numbers you want. I'm not sure of a situation of where they wouldn't break this proof. So if we just, I mean, I guess let's try some numbers here. I'll go to red for part B. If P less than 0 and Q less than 0, let's just take P equals -2, Q equals -2, and just see what happens there. -2 plus -2 is greater than or equal to root 4 times -2 times -2. So on the left side we get -4 greater than or equal to root 4 times 4 is 16. -4 greater than or equal to 4. That's certainly not true. And I can't think of negative numbers where this would work, because left side you just always get a negative number. So when they just ask you to show a counterexample, you don't need to. I still don't know what the point that you're making, Jeff, is. Like, if I did something wrong, or if you're just trying to add more information. But that final blue line on the bottom there, it would be true for negative numbers, wouldn't it? Well, yeah, I hadn't even gotten to that part of the proof yet. I was just, Thunder was asking about the first part of the proof, so I was explaining that part. Is that what this was about? Like, the question was, like, why do we get to this stage? So I was answering that question. So that's true. I hadn't gotten to the end of the proof yet, but like, yes, we do need to use the positive number given information to get to the very end here. Oh, okay. I guess that's what the miscommunication was. No, I wouldn't say that was the end of the proof, but I was just getting to this line in the proof. Trying to match what the answer key that Thunder gave does, because I think it's gonna be the most helpful way to show it. Brain fried. It's a weird question, Thunder. No, I wasn't able to catch Zach's stream today. Do you remember in that last part? Well, okay, so from the stage that I got to on the board, or from like the stage that we're working on here in the proof, we're not done yet, because we've proven that p plus q squared is greater than or equal to 4pq. But the original question was p plus q is greater than or equal to root 4pq. So we do need to square root each side. I don't know what that means, Jeff. I don't know what the subset lattice is. So I guess the work I've done is basically like, the halfway point in the proof. We have to square root each side, and when you have an inequality involved, you have to make sure that you're not like violating your inequality and need to flip it, basically. So if you have to show a simpler case, if you have negative x is greater than or equal to 1, you might solve that for x by, multiplying both sides by -1. That's what I'm trying to figure out in my head, honestly. Like, I still haven't figured out the justification, but like, there's a situation here where, like, when you multiply by -1, you need to flip the inequality. And I feel like I used to know the rules super well for when you do that, and now I'm rusty on it. And so when you square root each side, You need to justify, in this case, why you don't flip it. But that's basically, like, we're showing that we don't need to do it in this case because we don't have negative numbers involved being multiplied, I guess. Or we're not potentially changing the sign by square rooting. So, sorry, Thunder. I was saying, like, the situation that can happen with inequalities, we're trying to show why it doesn't happen. Square rooting does not change it, but we need to say why, basically. And so if you do the reverse and square each side, sometimes you get weird things with the signs. But from this stage, what we want to do is we want to take the square root of each side. But we need to show that we don't need to flip the inequality. And this is where you need to use the fact that they're both positive numbers. I think it's basically what Stuki said, to be honest. Like, or it really is what what Stuki said. You can't have a square root be equal to a negative number. Oh, that's absolute value. So like the absolute value of x, or like if you, it basically always turns the number positive. So the absolute value of -1 is +1. The absolute value of 2 is still +2. Like you basically just, you always make it positive. Okay, so yeah, actually, I like what. Okay, so that's what Suki was saying, but I couldn't connect like the very last dot there, which is why I was like trying to stall for time. But what Jeff said is basically if you square root something squared, you technically get the absolute value of that thing out. And then this is being super like careful with your signs, but because p plus q is greater than 0, these absolute value bars are redundant because it's never going to be a negative number, so then we're allowed to get rid of them. In that part, the answer key actually like skipped over, I guess, or justified in a different way. Well, it kind of like it like implicitly did this, I guess, but okay. Sorry, that was like fumbling around with that explanation. I'm like, the rules of like absolute values and inequality is just they trip me up a lot. So if p and q were negative, those absolute value bars would come into play, and you'd need to make 2 separate cases. And you get something that isn't true because the original question wouldn't be true in that case. Yeah, I mean, them not having the same sign makes the entire thing just go to crap. Oh, and things got safe. Yeah, dude, inequalities are so annoying to deal with, and especially when you're doing it's like, it's easy enough to remember if you multiply or divide by a negative number, you flip it, but then there's like squares and square rooting and things like that you have to care about. My nose is running so badly right now. I'm just gonna go in quick lead. Another one of these months, you're really not confident with it. If you want to see it, I'll do it. But if you're done thinking about math, then that's completely fair. You're just looking at it, you're dying inside. It's up to you, Thunder. If you want to work on it now, feel free to post it. If not, it's all good. Oh, here it is. Okay. Oh no, more inequalities and square roots and squareds. You're making me work overtime right now too. You'll try to understand? Okay. And no worries if you, at any point, you just want to say you're too tired. Let's work on it another time. Okay. It is claimed that the following inequality is true for all negative numbers x and y. X plus y is greater than or equal to x squared plus y squared. Oh, it's an erroneous proof. Okay, this is at least a little bit nicer. We don't need to come up with crazy steps on our own. Oh, well, okay, I just read part C. We might need to come up with crazy steps, but... The following proof is offered by a student. They square each side. They multiply out the left side. And they subtract over the x squared and the y squared. So I assume the errors are going to be in the squaring part, because the steps after these look valid. Wait, true, x and y are both for all negative numbers x and y. Jeff. Okay, yeah, so zero isn't allowed because it's negative numbers. You think it's both? Oh, wait. Yeah, this statement can't be true. If x and y are both negative... Oh, wait, no, it's greater than. But no, a square... something on a... Wait, so did the student make an error? I think the teacher giving the student probably made an error. This is never true. Yeah, Jeff is right. So the question itself is just bad here, Thunder, because x plus y is a negative number because x and y are both negative. But a negative number, and something square rooted is always positive, but a negative number can never possibly be greater than or equal to a positive number. So I can break it down a little bit more clearly if I put it on the board. Because I don't see the error in the actual proof. It's just the bad starting assumption, I think. If the student was set up to fail, it's how I'm interpreting it so far. So I don't know if that really counts as their error or the teacher's, but... Basically, Jeff got it right? Okay. If we have x plus y, if we're given this, x plus y is greater than or equal to x squared plus y squared, where x and y are both negative numbers, importantly. X plus y, when they're both negative, must be less than 0, because a negative number plus a negative number is less than 0. Whereas something square rooted, you know, positive number x squared, y squared is also a positive number. Positive plus positive is positive. Square root of positive is still positive, so this is greater than 0. And all three of these things can't all be true. Like, or like this line can't be true and that line can't be true, because left side is less than 0, right side is greater than 0, so this sign is completely flipped. Is at least what Jeff was saying. Sent the answer on the Discord. The student had forgotten the significance of x and y both being net negative, i.e. the left-hand side is negative while the right-hand side can be positive. The student didn't forget that. The student was given a bad problem. That feels kind of mean to the student. The student's work was fine, but they were given the bad inequality. Yeah, this is, I don't like this question, but so yeah, it's just the premise of the question is bad. How does one do part C? Prove the inequality is true if they're both positive. That's a good question. I assume we're gonna have to do something, that's for sure. Hey, Mangoes. Okay, so let's see, I need to take down the cam in the browser. You know, hate the question too? Okay. Oh, that's true. The student did do that, I guess. All right. See you, Gut Save. Thanks for hanging out. Okay, so that's a good point too, Stuki. The student did the same thing that I did, where they started out by assuming that the end goal is true, which defeats the purpose and is a logical error. They should have worked with just one side of the equation and gotten to the other side. This inequality is true if x and y are both positive. I don't know exactly how we're going to do this. Let's just try doing stuff. X plus y is greater than or equal to root x squared plus y squared. So where x and y belong to positive real numbers. I guess, like, we could try work with x plus y and squaring it. So, like, if we said x, like, just as exploration, let's look at what x plus y squared is, just in a vacuum. X squared plus 2xy plus y squared. Actually, I think it might follow the same structure as the last one. Because could we say that we group the x squared and the y squared together? Since we're working with positive numbers, we know that it's greater than or equal to x squared plus y squared, because 2xy is going to make this entire thing bigger, so if we take it away, we've made it smaller. And then do we just do the same like justification with the square rooting now? Because if we square root each side, oops. Root x squared plus y squared. That becomes absolute value of x plus y. Oh my god, that's not an x at all. Greater than or equal to root x squared plus y squared. And then because x and y are both positive, we're allowed to drop the absolute value. So I think it's actually the same exact proof structure as the last one. Yeah. If sine x is greater than sine y, does that mean x? No. Right? I don't know. Wait, does it? No. Because sine of 0 is greater than sine of 3 pi over 2, but 0 is less than 3 pi over 2. Oh, okay, okay. Sine's not strictly increasing. That's the rule, okay. No worries, Thunder. And thanks again for the raid last night, Mangoes. Hope you're able to get some good sleep after that freaking long haul of a stream you had. Oh, you're playing Civ. Ooh. Well, hope that was fun too. This question is actually genuine torture. Dude, the question but before this one, I was pretty lost too, so I'm right there with you. Okay, so I mean, of course, if you have anything else, feel free to post it. If not, I'm gonna go back to look around on the internet. Kurtosis? Never seen that word before in my life. No more questions? All right, sounds good. P and Q are points in the line 4x plus 3y equals 12. Complete the coordinates of P and Q. Oh, okay. So no one's answered this yet. Basically, the idea is just understand between x and y coordinates. If you're given 0 comma something, that 0 must be an x coordinate. So you plug in 0 for x to the equation, you figure out your y, and that's your blank. Thought of some sick, twisted question from the back of your head? All right. You have me intrigued. Standard form, 4x plus 3y equals 12. This is with Reddit Enhancement Suite, RES. Otherwise it doesn't. Four times 0 plus 3y equals 12. So 3y equals 12. Divide by 3, and you get y equals 4. So 4 would go in the blank for p. Q is a similar process, but you're given a y coordinate and have to find x. Okay, let's see how far the person gets with that. If they reply back, I'll say more. The darkness should be left in the deepest pits of hell in the Discord. You don't know, it's not bad, you don't know why you... Oh gosh, we got alphas, betas, and gammas. Let's see. How do you obtain this? Alpha cubed plus beta cubed plus gamma cubed is equal to... This is one of those reverse engineering ones. You start with the... Oh my god, it's just like a factoring trick. Yeah, it's what Jeff said. So you this is a trick that's used not too uncommonly in like weird algebra things. You basically, you know, if you start with alpha cubed plus beta cubed plus gamma cubed, you know all three of those terms are going to show up in like this form where they're in parentheses and cubed. So I'm gonna use x, y, and z because Wolfram Alpha, it's gonna be too much of a pain to get Wolfram Alpha to get the alphas, betas, and gammas. But you can see here, if we instead look at the case where we have parentheses in cubed, we have an x cubed term, a y cubed term, and a z cubed term. And you basically, you have to subtract out everything that's not those three terms. And so they did some fancy like factoring at the same time. But I also want to show it on the board because it's like it's a rearrangement, really. So they basically just, they happen to know that, well, here I'll do the actual Greek letters. Alpha, beta, gamma cubed is equal to alpha cubed plus beta cubed plus gamma cubed plus some other whole huge mess that I don't want to copy down from Wolfram. And they did a rearrangement of that where they subtract this alpha cube plus beta cube plus gamma cube, or they basically, no, I'm sorry. They keep that on that side and they subtract that like ... the everything else. So you can also say that alpha cubed plus beta, or it's alpha plus beta plus gamma cubed minus parentheses the ... that's there, whatever that is equal to alpha cubed plus beta cubed plus gamma cubed. And so if you ever have to start with alpha cubed plus beta cubed plus gamma cubed, you can remember this like trick where that whole factored out thing, even though it's gross, this kind of like more complicated format is sometimes helpful for getting cancellations. Now the thing is, in that ... they already did some factoring without actually showing it to get into a different format with that extra stuff. That's not it. Did I... Oh wait, they might have done it twice. They might have done the trick a few times. we do have the 6 XYZ as a term here. So, okay, maybe we do need to write out the entire thing, unfortunately. Oh, that's annoying. So to remember this? Oh, that's so easy to remember. It's basically, it's a rearrangement of all these extra terms here. They factored a whole bunch of stuff. So actually, it might not be that bad. Let's just see. You're right. That is like a problem that is from the darkest recesses of your mind. 3xc squared. 3 beta gamma squared. Plus beta cubed. I should have given myself more room. 3 beta squared gamma. Three beta gamma squared plus gamma cubed. Okay. So that's the entire thing. That's this whole thing factored out. We were interested in alpha cubed plus beta cubed plus gamma cubed. So let's group up those 3. And then from everything else, so I'm just gonna kind of have the benefit of knowing the end result here. Add a larger whiteboard to Don's. I mean, honestly, I do. It's more just like I need it to be mounted on my wall because like when I'm sitting in a chair, it's so awkward to go all the way to the other end of the whiteboard. But getting it mounted on the wall is kind of a huge pain. I don't know a good way to do it. But yeah, so we'll notice everything except for the alpha cube, beta cube, gamma cubed has a 3 in front of it, except for that 6 alpha, beta, gamma. They split that up into a 3 alpha, beta, gamma plus 3 alpha, beta, gamma. And time to learn one note, yeah. Is it okay for you to ask a weirder question? So I think it's just a bit long. Sure. Are you okay with not seeing that one then, or do you also want to see them both? Skip it? All right. It's basically just some fancy factoring, but at the end of the day, if you just need to know it, then you don't need to know why it works. But yeah, tricks like that are decently common with like, especially competition problems, I feel like. I never really encountered them in my normal like calculus class though. You would just send a painful one that took you 20 minutes. Oh. Oh no. The Quartic equation, x to the fourth minus 40x cubed plus 510x squared minus 220x. Oh, wait. I know how we do this. We are going to equate coefficients here. It's annoying that we have 2 constants to solve for, but we're going to get 4 equations. 5 equations. Oh no, it's going to be so much math though. Oh god. No, there must be a better way. Something to do with geometric series? Yeah, then the default way I would do this would be a huge pain. A geometric series? Oh. Torture the streamer. Yeah, I'd still rather do this question than anything that Jeff has asked me, so. Is that important, Jeff? I don't know how we would use that, but. Yes, sir. Oh, okay, I was. You could be a real Chad and rational root theorem this. Oh. It's called like someone's formulas, aren't they? Like it starts with a V, I think. Is it those? Well, yeah, Jeff, so that's the way I was going to do it, but multiplying that entire thing out is horrible. Sum of root product. Okay, yes, yeah. It's related to that. So I was Quartic. I'm just gonna look up Quartic Roots and see what comes up because I don't want the Quartic equation. It's horrible. Oh, thank you, Thunder. Oh god, lifesaver. Vietas. That's the thing I was thinking of, yes. This might be Vietas formulas, but either way, this is definitely what we need. So yeah, I think we're gonna. So you don't know the fastest method? I don't imagine there's gonna be a faster method than this. Oh wait, I haven't found the exact same thing on this page too. I just didn't actually look at it. At school from that's true. That is much faster. So are those Vietas for primos or is that something else? Wait, his name is Francois twice? Oh, never mind. Okay. I just saw that like Francois Viet Francois. It's like ooh, the double Francois. I'm just getting distracted though. yeah, but then I don't know the fast way to do it than that way. I think it is Vietta's formulas of the way that I've heard of it. So if you want, I can go through and do it still, but it'd be doing the same method that you sent me here. See you later, Jeff. Try it? All right. It is going to be a lot of multiplying, unfortunately. We can reuse some of our work here. Oh, wait. We have a trick. We do have a trick. Okay. You don't have to use all 4 of these formulas. We are only going to have 2 unknowns here. And whenever you have 2 unknowns, you only need 2 equations to solve. So we can choose whichever 2 of these are easiest to work with. So the first one is, I think, the easiest out of them all. And I think the last one is the next easiest, unfortunately. Yeah. Okay. So x to the 4th minus 40x cubed plus 510x squared minus 2200x plus 1729 equals 0. Should write on the top left. I should, but I don't feel like reaching all the way over there. Our roots, x equals alpha, alpha plus 2k, alpha plus 4k, alpha plus 6k, right? Right. Now we need to apply our formulas. Formulars. Okay, so we're going to use the first equation here, which is all 4 of the roots summed. So let's sum them all up. Actually, we can do a little bit of a shortcut here too, because we know the alphas are going to all add. So we're going to have 4 alpha plus 12k is equal to minus b over a. So 40 is already minus, so just 40, and over 1 is just 40. Okay. So that's our first equation with 2 unknowns. And then the part that's going to suck is the product part. Alpha plus 2k, alpha plus 4k, alpha plus 6k is equal to e over a, and e is the constant. And a is 1, so it's just 1729. Okay. So I'm going to multiply these 2, and then I'm going to multiply those in 1 by 1, I think. Actually, yeah, why not? It doesn't matter. Alpha squared plus 2k alpha. Do you write k first or alpha first? Sorry, just a weird noise. It doesn't matter. Okay, let's multiply into alpha plus 4k. Alpha cubed plus 4 alpha squared k. Now I'm already mixing up my order. It's going to be 6 alpha squared k. Plus 8, oh god, alpha k squared. Alpha squared k, alpha squared k. Okay. Alpha plus 6k, right? Oh, you could substitute. I just like doing it. I mean, actually, well, no, I don't think substitution saves you that much work, unfortunately. I'd also just rather do it directly personally in the situation. If it's... Yeah. For me, it's just more clear if you just do it directly. Now I'm going to multiply in the alpha plus 6k in, so the alpha gets multiplied into everything first. Alpha to the fourth plus 6 alpha cubed k plus 8 alpha squared k squared plus, 6k times everything. 6 alpha cubed k plus 36 alpha squared k squared plus 48 alpha k cubed is equal to 1729. Okay. Now let's combine like terms. Oh no, wait. Oh no, it's gonna be horrible to do still. Oh no. Okay. I'm doing it though. Because even like solving the system of two equations is gonna be really annoying still. But I'm doing it. I started a problem, I'm not gonna stop. Alpha cubed k, alpha cubed k. Alpha squared k squared, alpha k, alpha, the words. 44? 8 plus 36, yeah. And just alpha k cubed. Ugh. So, yeah. Now I'm gonna solve that one for... I want to avoid doing another to the fourth, so I want to plug something in for k here. So I'm gonna solve this one for k. Everything can get divided by 4 as well. Alpha plus 3k equals 10. K equals 10 over 3 minus 1/3 alpha. We'll take this thing, plug it into the k's here, and we can at least avoid having to do something to the fourth. We'll have to do something cubed, but... Wait, we're gonna have to solve a quartic, though. Oh, God. 12 alpha cubed times that. 40. No, 4. No, 40? Yeah, 40. Alpha cubed minus 4 alpha to the fourth. That's that term done. That term now. 44 alpha squared k squared. I'm just gonna... Actually, let's do k squared separately up here. K squared is equal to... Dude, this is... I don't know how we're going to solve this quartic. I hope it boils down to something nice. 100 over 9. Minus... why can't I do that math? 10 over 9, 20 over 9 alpha plus 1/9 alpha. You got this? Thank you, Thunder. I need all the moral support I can get right now. Because that's k squared. I'm going to plug it in down here. Watch, I'm going to make some stupid arithmetic mistake. Plus 48 alpha. I'm going to do the cubed part later. Or separately. Okay, we have an equation only in terms of alpha now. Let's combine what terms we can over there. We have alpha to the fourth minus 4 alpha to the fourth. 40 alpha cubed. Distributing that 44 alpha squared. 40 400 over 9 alpha squared minus 44 times 20. 88, add a 0. 880 alpha cubed over 9 plus 44 over 9 alpha squared. Alpha to the 4th. Oh my god. The answer is whole, but the quartic is nasty. Yeah. Okay. We need to work out what k cubed is, so we need to take that and multiply in another k. Oh, God. Is rational root theorem better? What are the factors of 1729? I thought this would be a lot nicer. Actually, oh wait. Maybe the second equation was better to avoid this quartic. You know what? I think I'm actually on the wrong thread. Because even though it's a lot of individual multiplication, yeah, I just realized that for myself too. It's a lot of individual multiplication, which is why I avoided it, but this is actually better. Okay, no, I'm not discouraged by that. Okay? Because now I know for the future to not even bother with that. I didn't think it would be that bad, to be honest. Okay. It will be a little annoying, but alpha beta is alpha squared plus 2 alpha k. First term, done. Alpha gamma. Oh, those are just the roots. Okay, so alpha gamma is that. Alpha squared plus 4 alpha k. Okay, so to know, they give you 10 minutes? Oh, dude, that's like, I went down the wrong train of thought there, and I wasted probably more than 10 minutes doing that. I guess, I don't know, man. Just gotta have better intuition than me, which probably isn't that hard, but it seems like you're expected to know a ton of different stuff. Like, it does not seem easy. Okay, that's alpha delta. Now let's do beta gamma. I should have written this further to the left. Beta gamma. I can't remember. Oh, yeah. Gamma is the third Greek letter. Beta delta. Alpha plus 2k, alpha plus 6k. And then gamma delta. Is equal to c over a. The squared term, 510. I do want to investigate the rational root theorem angle as well here, after we try this. Oh my god, okay. Do you know the rational root theorem, Thunder? Because this is actually this is pretty painful too. Okay, multiplying that out. Actually, wait, I should combine like terms there. Save myself a little bit of work before I get to the multiplying. 3 alpha squared. 2, 6, 12. You haven't learned the rational root theorem? Oh god, I think it'd be a bit easier. Or it wouldn't be the easiest, but it'd be easier than this frickin' this like busy work here. Alpha squared, we're playing this out now. 6 alpha k plus 8k squared plus, multiplying this out, alpha squared plus 8 alpha k plus 12k squared, multiplying that out, alpha squared plus 10 alpha k plus 24k squared is equal to 510. Okay, combine like terms. 3, 4, 5, 6. 12, 18, 26, 36. K squared. 8, 20, 44? Wow, 44 is showing up again. That's funny. So in alpha, I can check if you're wrong using the MS. Okay. Oh, like use alpha for the sub here? Okay, yeah, so here, yeah, it doesn't really matter if we do use alpha or k, so I'll sub this for alpha. Say alpha is equal to 10 minus 3k, and plug it in over here. 10 minus 3k squared plus 36, 10 minus 3k k plus 44k squared equals 510. Okay. 100 times 6 is 600. 10 times 3 is 30 times 2 is 60. 60 times 6 is 360, just like the Xbox. Yep. Plus 9 times 6 is 54. K squared. Okay. Plus 360k. 36 times 3. 18 plus 90 is 108. K squared. 44k squared is equal to 510. Okay, we're nearly there. K squared, 54, that's 98. An awful number. Wait, minus 108. I missed that case. Wait. Yeah, okay. That's 10? 10. Minus 10. K is minus 360 plus 360. It goes away. 600 minus 510 is 90. Plus 90 equals 0. So minus k squared equals minus 9. K equals plus or minus 3. Oh, I could divide it all by 2. You're right, Thunder. I didn't even spot that. But it's not like I got to the right answer anyway. Yeah, divided by 2 would have saved some work there. It's okay, though. Okay, so we know K. Let's find alpha. When K equals positive 3, alpha is equal to 10 minus 9 is 1. When K equals negative 3, we get alpha equals 10 plus 9 is 19. Only one of these can be valid, though, I'm sure, right? Or only one of these combinations? How do we know which one? I'm making a mistake? I believe you. Were we given something about alpha? Yeah, I figure we're given something to distinguish between these two. Some real constant k. Wait, both these k's are real constants. All of them are right? You get the same answer? That's kind of crazy. So let's take k equals 3 and find out what our roots actually are, just like with Scooby-Doo. Let's find out what our roots actually are and take the mask off. So alpha, we said is 1. And then we have 1 plus 2 times k is 7. 1 plus 4 times 3 is 13. 6 times 3 is 18 plus 1 is 19. Or, with the other case, k equals minus 3. Alpha is 19. Ah. Okay, so we're going to be going backwards, I guess. 19 minus 6 is 13. 19 minus 12, 7. 19 minus 18 is 1. Oh, that's kind of cool. It works out both ways. If you ask your teacher, he just told me don't look into it too much. It's a geometric series. That's interesting. I assume the derivation of those, like, sum product formulas have to do with... Yeah, here you are asking me. I assume the formulas are derived from geometric series, and not sure. Hey, Central, solve a Rubik's Cube. Oh, you know, you picked a good time. Hope you're doing good today. Ah, that's a nice, like, mental break. Okay. Okay, I need to remember, like, what the heck direction is down? Okay, it's like that. F2, R2. Back is like that. Okay. Base, R2, D2, R2, D2, U, R prime, D, R2, U prime, L2, F, L prime, D2, speed. Okay. Scrambled. Click in, inspection time. Oh my god, where are all my pieces at? This is really bad, bad RNG on the scramble, man. Oh god, I don't, I did it right! I hadn't done this algorithm in a long time, and I don't quite have the muscle memory for it. When you have like that case where just the very last rows. There we go. But yeah. So not a bad time. The it was a really bad case for trying to to solve it quick. Do it in 3 seconds now? That I can't do. It's the world record, I know, or it's something like that. You're done asking questions? All right. Good night, Thunder. Thanks for being here, for giving me questions. Honestly, it's so close to I didn't think I'd have any. So I'm glad to be able to do some math. Let's see if this person got back to me on this thread. No, they have a bunch more answers though, so I'm going to leave it. Oh, you know what? I do want to look at the rational, even though Thunder's gone, I still want to see what the rational root theorem would have looked like for that Quartic. Because you can just see. Oh, dude, that'd be so much easier. The periodic table. Oh my god. The rational root theorem would have been so much less work for this. Get fucked. I mean, I don't say my disclaimer is I crappily draw it, so I don't have to do every last thing. Get fucked. Get that problem off my whiteboard, for the love of God.